Let's take a look at this identity. Again, we're supposed to prove that the left side of this identity is equal to the right side. This time I'm going to start from the left side. Let me copy this down. I have tangent square alpha minus sine square alpha. Tangent square alpha I can rewrite as sine alpha over cosine alpha to the second power minus sine alpha over 1 to the second power. Someone is going to ask, why did I convert this sine square alpha to the fraction? Because I have fraction over here. I'm going to subtract fractions. So I can rewrite this as sine square alpha over cosine square alpha minus sine square alpha over 1. Next, I'm supposed to find the common denominator. Common denominator for these two fractions is cosine square alpha. That's why I'm going to copy down first fraction, sine square alpha over cosine square alpha minus cosine square alpha sine square alpha over cosine square alpha. Next, I'm supposed to perform the subtraction. So I'm going to have sine square alpha minus cosine square alpha sine square alpha over common denominator cosine square alpha. Next, I'm supposed to factorize sine square alpha. So I'm going to have sine square alpha, and inside of the parentheses I'm going to have 1 minus cosine square alpha over cosine square alpha. Now, look at the right side. We're supposed to have tangent square alpha times sine square alpha. Sine square alpha over cosine square alpha is going to give me tangent square alpha. Now, what about this sine square alpha? Please notice that this is nothing else, just the Pythagorean relation. Pythagorean relation says sine square alpha plus cosine square alpha is equal 1. If you are going to solve this relation, this formula for sine square alpha, you will simply move cosine square alpha to the right side of this formula, and we are going to have sine square alpha equals 1 minus cosine square alpha. So we can say that 1 minus cosine square alpha is nothing else, just sine square alpha. That's why I'm going to rewrite this as sine square alpha over cosine square alpha times sine square alpha over 1. 1 because my denominator is cosine square alpha, right? So this is cosine square alpha times 1 gives me cosine square alpha. So this is the proper notation. And sine square alpha over cosine square alpha gives me tangent square alpha, and sine square alpha over 1 gives me sine square alpha. Now, please take a look what we have over here and what we have on the right side of the identity. These two expressions are identical, so it means that we prove that the left side of the identity is equal to the right side.